As you probably know, Elon Musk has co-founded and started many companies from his early days, starting Zip2, X.com, which became PayPal, and OpenAI. Today, he's currently the CEO and running The Boring Company, Neuralink, Twitter, and of course, SpaceX and Tesla. These companies together are sometimes referred to as Musk Industries. And what he's demonstrated frequently is how these sister companies often will share technologies and benefit each other. Today, we're going to be exploring how SpaceX and its Starlink satellite internet constellation can and will be a major benefit to Tesla, both the business and the stock. One person that I found that has a unique experience and background to help us do this is Julien Villa-Massone. Thank you so much, Julien. I'm really excited for you to join us. Appreciate this.
Thanks, Herbert. I'm very excited to be here. Thanks for having me.
Absolutely. So Julien is an airline pilot. He's a software engineer and a multi-startup founder. As you'll see from today's conversation, he is terribly passionate about space exploration. He currently works as a 737 pilot and is building a software startup in satellite communications, contributing mostly as a software developer. Julien's startup has been working for 2 years on simulating Starlink and other constellations, supporting a geo-satellite operator to better understand its future competition. So a quick background here on why and how Starlink might benefit Tesla. Tesla was actually the first Musk company to go public. Thanks to Elon Musk's ambitious vision, engineering skills, and tenacity, Tesla has at one point reached a $1 trillion valuation, mostly based on the auto business, but other businesses will be added to Tesla's valuation, including transportation as a service, energy, AI, and robots. As a result, many are predicting now that Tesla will be worth multiple trillions in 10 years. SpaceX is the second most valuable Musk company, valued in January of 2023 at $137 billion, following this private capital raise of $750 million. Starlink will need to raise capital on the public markets as a spin-off via an initial public offering once it's ready to accelerate deployment. So there's two ideas for us to discuss. First, will Tesla's investors buy Starlink stock? Will those investors need to sell some Tesla stock? And then how much percentage of Starlink versus Tesla should investors hold? A valuation of Starlink is needed to understand this. Second, Starlink will benefit Tesla. And we're going to explore all the ways that it can do that, and therefore it'll benefit Tesla stock. Elon Musk confirmed that satellite access will be provided to Tesla's cars. But how and when will this happen? And how will Tesla benefit from the service? Well, Tesla has the monopoly today for internet via satellite, but for how long? All right, well, thank you, Julien. We can, really discuss these different viewpoints together and help me get brighter. So Julien, thank you so much. Now tell me, I know that you're quite excited about Starlink. How did this all happen? When did you begin? And tell me your story.
Yeah, absolutely. So I think about 3 years ago, when SpaceX started to launch satellites, right? I became super excited because I thought, okay, now we can have access, to internet, high speed, like fiber, from anywhere in the world. And that's a first because low latency was not available until Starlink, basically. So I thought, okay, at least I want to know where those satellites are. So I built a website called satmap.space. And this website shows you where the satellites are. So back in the day, there was 10 satellites, 50 satellites, not so many. But now you have 3,600 Starlink satellites. And so you can see them orbiting the Earth. And so this website doesn't show only Starlink, it shows also other constellations like Iridium, Intelsat, SES, Orbcomm, most of the communication constellations. And as you scroll the website, you realize that Starlink has a lot of satellites. Now, one of those geo operators, so geostationary satellite operators, legacy satellite operators, just like there's legacy auto, there's legacy satellite. And so one of my friends working there said, hey, we're using your website at work. Can you help us better understand what Starlink will become, and what other constellations will become? So, we've been working together. We founded a company, a little startup / consulting company. And what you see here is Starlink operating. That's in 3D. So you can see what satellite is serving what area on the ground, with what beam, we can calculate a lot of performance metrics and understand what is the capability of the constellation. And we also have another version that we can show, which is,
this one?
yeah, if you can, yeah, exactly, this one. So here, it's the same thing, but now we have residential demand. So we simulate the demand. Who is using Starlink, where, how much bandwidth is needed by those customers. And you also can see airlines. We added airlines here. Some of those airlines that will get Starlink on board for passengers. And we also did cruise ships. It's not shown here, but essentially we add all the demand, and then we add all the satellites at a point in the future, not necessarily what you have today in the sky, but what you will have in 2 years, in 5 years, in 10 years. And this way we can predict, understand what the landscape will be for satellite communications. And this is why our customer uses us as a tool to better understand their competitive landscape in the future.
That's amazing. It's amazing how much data you have. And this is so beautiful. This is beautiful. So everything I'm looking at here is a satellite, a Starlink satellite, right? And you're tracking to see with the pink area, the coverage that it can do. And this is like a point in time.
Yeah, so what we see here, so the blue areas is areas on the ground. That's representing the Starlink cells where users are. So sometimes you have cells that are very densely populated with subscribers, Starlink subscribers. So these people might have a lower bandwidth available to them because there's so many people sharing the same beam, And in some other areas, which are represented as light blue, so dark blue is dense areas and light blue is sparse areas where there's not so many subscribers, and so you have a lot of bandwidth available to you. And so, as you mentioned just now, the pink lines essentially are beams, where the satellite forms a beam towards a cell, and then that is like transmitting data, okay? And so what you see as cones, conical shapes, are actually a bunch of lines representing a bunch of beams going from one satellite to a lot of cells on the ground, and this is how Starlink operates.
Nice. Okay.
I might add one thing specific to Starlink. It's the first time that we see a constellation with so many satellites being at such a low altitude, which is around 500 kilometers. And so they move so fast that the allocation between a beam and the target cells on the ground, this allocation cannot stay for a very long time. So every 15 seconds, the arrangement of beams is changed. So there's a central calculator, a central algorithm at SpaceX that calculates all these beam allocations, and then the whole system implements them, and every 15 seconds, you see the beam changing and changing and changing. So it's very new, and it's very fascinating. It's really incredible, that keeps me awake at night, essentially.
Yeah, absolutely. Yeah. I can tell why. It is gorgeous what you did here. This is what you guys are doing, tracking all of this. All right. Well, then from that, what exactly is, tell me more about what you know about Starlink and how this works. So this is the different versions. Yeah.
Exactly. So I think one important point is that Starlink is in constant evolution. It's never like standing still. SpaceX is launching like rockets every week, it's insane the launch cadence they have. Okay, so what we have today orbiting the Earth rather in the sky is Starlink version 1.0 and 1.5. That's already orbiting. We have 3,600 satellites of this version. Okay, this is version number 1, and SpaceX is starting to launch version 2 now. So version 2 is those two satellites you see in the middle, 2.0 Falcon 9.1 and 2.0 Falcon 9.2. So Elon Musk told us that 2.0 has a better capacity, so more bandwidth, more gigabit per second for each satellite to send to cells on the ground. That means everybody gets a lot more bandwidth, okay? Or there can be a lot more people sharing more bandwidth. So the thing I wanted to mention here, and the reason I made this slide, is that V2 Falcon 9-1, this satellite is the same shape as the previous generation. So it's slightly better. It's better, but it's not like crazy better, okay? But if you look at version 2.0, Falcon 9-2, this one is larger. It's a larger satellite. So it cannot stand horizontally in the rocket. Like normally there's a stack of 30 satellites and 2 satellites side by side, okay, like pancakes. And that's the previous generation. But this generation, Falcon 9-2, is going to be vertical. So you'll have a lot of satellites vertically lined up in the rocket going up to space. And so that's what allows them to make a bigger satellite. And I think the reason they do it is so that they can fit the direct-to-mobile antenna, because it's a very big antenna. So that is my assumption. I might be wrong on this, but I think so. Because in the end, they will send less satellites per rocket, but in the end, it's going to be cheaper. Okay, I want to touch upon the final satellite on the right side, which I think is the most important one. It's Starlink 2.0 Starship. And so this one is even larger. It has the same width as the Falcon 9-2, but it's longer, so it can fit in the Starship rocket. And once they get to this version and Starship starts to launch on a regular basis, then the capacity that is put into orbit for each launch is going to be incredible. So if you look at the 4th row here, terabit per second per launch, we go from 1 terabit per second per launch to 8.5, right? So it's a lot more capacity. And they're going to send a lot more of these satellites than what we have today. And the effect of this new satellite design and using Starship, that's 2 effects that will really lower the dollar per megabit per second, which is what you end up paying at the end. The line that is, the second to last line, dollar per megabit per second, we see that we go from around 50 to 9. So that's a drastic reduction in cost. Okay, so those are the points I wanted to mention here about the different versions of Starlink. And as soon as Starship becomes available, SpaceX will launch just these satellites.
So what is your timeline that you're expecting this to happen? So we are currently in Starlink version 1.5. That's out there right now. But Falcon 9.1 and Falcon 9.2 those are happening currently today, right? And in Starship, isn't it just they did a burner test just recently? So what is your time frame on when they'll actually start doing Starlink version 2?
So my understanding is that they already started to launch Starlink version 2. I haven't checked to be honest. I think they launched the first batch in end of December, so 2 months ago, and more in January. So I think they're launching just these now. And then when will Starship happen? So the first launch, I think, will be in March. So in just like maybe 3-4 weeks, we will see Starship launch into orbit carrying these satellites. I mean, they're not going to put like a Tesla in there like they did with Falcon Heavy. They're going to put some Starlink V2 satellites, and it's going to be crazy. I mean, yeah.
So you think the Starlink V2 is already created, though? And so there's 2 things here: the Starlink version and also the Starship capability, right? But both of these are available now. Okay, and then
and I guess the point I wanted to make is, so the first launch of Starship, like the orbital launch, will be maybe in March if FAA approval pending, But if it happens in March or in April, they will not start to launch like super regularly. It will be like maybe every second month or third month, and then it will accelerate over time.
Okay, so this is an incredible improvement on both the feature functionality of these Starlinks, but also because of Starship, they're able to make these Starlinks bigger, and then that will, as you've been saying, drastically reduce the cost and relative to the megabits per second, and to be able to do that. What is direct to mobile? I mean, I have an assumption of what that is. Is that like my cell phone?
Yeah, exactly. So you may have seen the event at SpaceX in Texas, where they invited T-Mobile. Yeah. And so the capability that we're talking about here requires a specific antenna on the satellite, and also requires spectrum available, so a spectrum license. In this case, SpaceX and T-Mobile decided to partner up. And so T-Mobile is using their 2 gigahertz license to let Starlink satellites beam directly to cell phones on the ground. So of course, that's going to be only in very sparse areas, not for cities, it's not useful, because the bandwidth is very slow. It's going to be, 18 megabit per second shared for an entire cell, which is maybe like 200 kilometers by 200 kilometers, or like 130 miles by 130 miles or something. So not a lot of bandwidth, but at least what you can do is send text messages, maybe do voice calls, SOS definitely. So it's the same as what Apple is offering, and I think they're using Globalstar if I recall correctly. So Apple and SpaceX will be competing here.
Okay, we'll be talking about that a little bit more detail, right? So just give us a little hint of the conversation as we move forward. Okay, so this is how it looks like Tesla or SpaceX and Starlink competes against its competitors. Go ahead and share me more about how that is.
Absolutely. Working. So here I selected a couple of Starlink competitors. Not all of the satellite constellations are here, but those are some that come back all the time in conversations. So I've put Telesat Lightspeed, I've put Amazon Kuiper, and then I've put OneWeb. So a couple of things about these is that OneWeb is already in orbit for the most part, so it's already service is available. Kuiper is not in orbit yet. I think there's only 2 satellites they're testing, but they already signed agreements to launch, and so I think it will become available, I guess, pretty quickly in 2025, maybe 2024 probably. And they need to launch, I think, the constellation by 2026. That's their deadline. And then Lightspeed, is a Canadian, Telesat is a Canadian company, but they also signed some agreements, and they also have the authorization to operate. So I think it's a worthy competitor. And so what do I want to mention about these competitors? I wanted to show that there's different types of satellites, different masses. So OneWeb is maybe an older generation already. Lightspeed might be like a better type of satellite. It's bigger. It's also designed for low Earth orbit. All of these are low Earth orbit satellites. And of all the competitors, Lightspeed has the best gigabit per second per satellite, right? But what is interesting for me is, okay, how many terabit per second do you put in orbit for each launch? So in this case, Lightspeed is not too bad. 1.5 is better than what we've seen even from Starlink from the previous generation. Kuiper even better. But obviously with Starship, Starlink is really topping that very easily. And the best, I think the most important part is the cost. So I think Lightspeed and Kuiper managed to be quite competitive with the current version of Starlink, but they can't really compete with Starship, according to my calculations and my assumptions. Also, I think that none of these constellations are able to do direct to mobile. I'm not sure about Kuiper. I don't think they plan to do it. They could surprise us or surprise me, if I'm not aware. But yeah, essentially, that's what I wanted to show to give an overview of the competitive landscape. And so then I prepared. Yeah, go ahead.
I could just looking at this slide again. You show that OneWeb, which is existing already out there already, but they're using Falcon 9, so they're using SpaceX to help them do that. Versus Amazon and the Telesat, they're using New Glenn, which is Bezos space.
Yeah.
Offering, right.
So yeah, I should mention that some of these satellites will be launched or have been launched by various rockets. Okay. What I've put in this row is not necessarily that they've been launched only by this type of rocket, but this is the rocket I've used for my calculations, which we will see later. And to give you an example, I think OneWeb launched with the Indian rockets, for example, and maybe with Russian rockets, but also with Falcon 9, which is incredible. An important detail, Starlink and OneWeb were sort of fighting over the, how can I explain that? Sort of the power that they can send on Earth, the frequencies agreement by the FCC, if you will. They were fighting over who has the right to use what frequencies and stuff like that. And then OneWeb realized, well, we can't really launch like we wanted. We're going to have to use SpaceX. And that helped those two companies find an agreement. And from that moment, they said, okay, we don't have to fight anymore. And SpaceX will launch OneWeb. So I think that was pretty cool.
And the other big number that we want to show again is the dollars per megabits per second. And Starlink is going to be at $9, and its closest competitor is at 34. That is like a 3 to 4 times difference and cheaper to be able to deliver this. And so it's going to be just such a huge competitive advantage. And Starship is going to be going hopefully on a regular basis, more frequent basis.
Oh yeah, the cadence, the launch cadence is going to be crazy, I think. And the fact that it's free to reuse, essentially. The Starship and its booster are reused 100%. So that lowers the cost, right?
Okay. Well, this is a good overview of the competitors, good overview of what Starship and Starlink looks like. Tell me more about the competitors, and then, but I can't wait till we get eventually with the use cases. That'll be fun. So, okay, show
Absolutely.
me more about this.
Yeah, so I just have a couple of charts here to show with numbers and with charts what's going on here. Because you hear a lot about Kuiper, at least in my work, like everybody talks about, oh, Kuiper is coming and OneWeb is doing this and that. Let's look at 3 numbers for each constellation. One is launched. So in this case, we look at the number of satellites, how many satellites were launched. Then some of those companies want to launch more satellites. So how many more have been approved? And finally, they want to launch even more, and how many more have been planned by the company, requested to the FCC for approval, but not approved yet, okay? So if we look at that, we see that launched, of course, Starlink is better with 3,600 satellites. OneWeb has about 500. OneWeb is not, as far as I know, not planning to launch more. I might be wrong, actually, but I think this is what it is for now. Kuiper has launched virtually 0 satellite, but planning, well, approved 3,000 and so, and planned also a lot more, like 8,000. Lightspeed has not so many satellites. Okay, what does that mean in terms of the gigabit per second available? Okay, that translates into a number of terabit per second, because each satellite can provide so many terabit per second, or gigabit per second rather. So if you compare those 2 charts, you see that if you look at Kuiper, for example, they have a lot of satellites, but they give you, relative to Starlink, very few terabit per second. And that's because the Starlink satellites are bigger and they can provide a lot more gigabit per second. And so Starlink, with a number of satellites, can be more efficient, essentially. It's just like comparing Model 3, which is efficient, to, I don't know, the Ford F-150, you know. It's not as efficient, so maybe it's not as good. So that is just to give some context. And on the next one, we can look into
before
more
we
data.
jump to the next slide, Doug, I just want to point out to here that this is a crazy difference. I mean, we already kind of knew that Starlink is so far ahead of its competitors, but this really in visual form shows us that if everything goes according to plan, we're talking about, what is that, 35,000 versus 8,000 in Kuiper you mentioned. So even just what they've got planned right now, that's a huge magnitude difference. And then the usable terabytes, again, it looks on your graph anyways, that it's just so far ahead of what everyone else is doing. So it almost looks like there really isn't really much of a competitor. Okay.
Yeah, and it shows you the vision of Elon Musk. You know, he's not saying, oh, you know, that's going to be too many. He's saying, this is what we need. It's just like Master Plan Part 3, you know. It's like we need to convert the entire world to renewables and to EVs and to batteries. You know, this is what we need to do to solve climate change. Well, to help solve climate change, right? So we'll do it. We won't play small. We have to play at the right size. And this is the right size to give internet access to everyone.
Nice. Okay, and this is your next slide.
Yeah, so now the question wants to know how many terabits and whatnot, you know, how many people can you serve? That is the big question, because each person will pay you a monthly fee, and this is how you can estimate your revenues. What I'm trying to do here is a valuation of the company, okay? So I'm going step by step. So how many subscribers can Starlink serve with what is approved today? According to my calculation, about 70 million people, which is a very large number for a constellation. I mean, these are numbers we've never seen before. Okay, this is for what is marketed at 50 megabits per second. So, of course, in the US, you know, people want 300 megabits per second, and so. But you have to consider also the entire world will be served. You know, not China, not Russia, but and probably not India. I don't know. But the rest of the world wants to have internet access, but they will not necessarily want 300 megabits per second. And so I'm just showing you here something that's representative of the entire world. So with what is planned, I think Starlink can get to almost 300 million subscribers. It's a large number. And if you compare to OneWeb or Kuiper or Lightspeed, you see there's such a big difference. It's insane, you know, the scale of Starlink.
Yeah, I just heard, just was it last week that every week, every month, we're hearing Starlink open up in a new country, and they're now just opened up Philippines just last week. So it's like they're going one after another. Africa the week before that.
Okay. Exactly. And the next question is, okay, well, that's all great that you can serve so many people and they're going to have this much bandwidth and whatnot, but how much is it going to cost? And obviously, Starlink is going to cost a lot more. If we just look at the planned version, then it's, according to my calculation, $55 billion US dollars. So if you look at what Starlink has launched already, let's call it, I don't know, 3 billion, or maybe it's even 4 billion. So this is an amount that, I don't know, Elon Musk and SpaceX managed to fund privately, okay? But if you look at what is approved now, it's 15 billion. So for 15 billion, can they raise that much money on the private market? I'm not really sure. If you look at the plan, you have to go public at some point. This is why they talk about the IPO. They look at these charts and they go, okay, we need to raise money because we need to do this as quickly as possible. We're not going to wait until we have enough revenues to then pay for the launches and manufacturing the satellites. No. We need to go as quick as we can. They just got the approval a few weeks ago, and now they need to go, okay? I don't know when the IPO will take place, but I'm suspecting maybe 2024, If you compare that to OneWeb and Kuiper and Lightspeed, again, this is less than 10 billion. Kuiper is a lot, so I don't know if they will need to do any IPO. I guess Amazon can easily pay this kind of money, but we'll see.
What I remember Elon saying about when Starlink or SpaceX will go IPO is when they have predictable revenue that comes in, regular predictable revenue. Are you thinking that Starlink will spin off on its own, or will it be part of SpaceX IPO?
That's a very good question. Honestly, I cannot answer this question. I just don't have sufficient information to help answer it. However, one point I wanted to make now that you asked this question is, if you look at Starlink version 1.5, as we saw before, this one is not very good economically speaking. So it's good technically speaking because it enables internet for everyone everywhere, but it's not very good to generate more revenues than what it costs, So that's why for now, it's not being a great business model. But the version 2 is what enables a great business model, okay? And so that's what we see here on the approved. The approved represent a great business model, whereas the launch represents a not very good business model.
Okay, so what you've talked about is that in order for Starlink to be able to do what it needs to do, they need to raise $55 billion. Where are they going to get that from? So, okay, tell me about this slide.
Exactly. So what I've done here is slightly different. I've said, okay, we know how many subscribers can all these constellations serve, and we know how much capacity they have. We know how much it costs to build this constellation. The question is now, with all this information, what is the price that subscribers will have to pay to access internet through these constellations for the company to break even? Okay, so this shows you, for example, if you compare the 3 phases of Starlink, that the cost to break even for marketed 50 megabit per second was around $17 per month per subscribers. So if you say that you sell 300 megabit per second, then it comes down to about $100 per month, which is what we're seeing in the market, okay? This is how much it costs, $100 per month. And what you get is around 300 megabit per second when you're lucky. Okay, but the next phase, which is the approved phase, that's going to be less than 5. So that's going to be 30. So for 300 megabit per second, it's going to be $30 per month. So you go from $100 per month to $30 per month, right? Of course, Starlink is not going to give this price. They're going to give higher prices. They're going to price depending on the demand, like they started to do yesterday. But I did this graph here to compare with others. Of course, OneWeb is a lot more expensive because it's already an older technology, sort of. Kuiper is going to be quite competitive, and the same goes with Lightspeed. You see, the prices are not so far apart because, relatively speaking, it's still pretty decent technology. The problem is how many, can they serve so many subscribers that the business model makes sense, right? And so that's when we come to the valuation of the company, when we just multiply how many subscribers by a certain price.
Gotcha. Yeah. And so what you're showing here, the lower the better. And once we get to the approved and to the plan for Starlink, we're talking about, it looks like they're $3 per month for every 5 megabits. So let's say you're talking about 30 megabits, or market is 50 megabits per second. Gotcha. So 50 times, let's say 6. So 6 times $3, $18, $24 per month to get up to 300 megabits per second. That's the cheapest that anyone can offer, and that's what you're showing here. Okay.
Yeah, exactly. But that's to break even. So Starlink also wants to make a profit, huh?
Gotcha. Okay. So this is the company valuation in billions. So based on all that, you put it all together, you're talking, wow.
Yeah.
Okay.
So before I go in this detail, I just want to mention the things that, like at the bottom, okay? Based on gross margin only. So I'm not talking about all the cost of running the company, or I'm also excluding the user terminal costs. So the antennas that go at home or on your RV or on the plane, that's not part of this study. I'm excluding any direct-to-mobile costs and revenues. And I'm excluding Starshield because that's a topic. I don't know if it's going to be part of the IPO or not part of it. I guess not. It's military stuff, probably not, but we'll see. So
wow.
Now, looking at the company value, obviously you see a difference, right? Starlink is higher, and OneWeb, you can't really see it because they just don't have a lot of capacity, so they cannot serve so many people. And Kuiper and Lightspeed, although they have good cost relatively, they cannot serve so many people. They don't have a lot of capacity. So if you multiply the price that subscribers will pay by the number of subscribers, which is small compared to Starlink, that's why you come to a company value of maybe 100 billion. But with Starlink, so first with Starlink, if you look at the launched, you see it's very small because it's not a very good business. If you look at the approved, it's already 400 billion. If you look at planned, 1.6 trillion. And now that I said that, I need to also add some information, which is, I have a lot of assumptions in this model, okay? You know how business models work. You change a little bit this variable and that variable, and then the bar goes up and down like crazy, okay? It's very sensitive. So to give you one example, I've put that the cost to launch Starship is $15 million. Elon Musk said they aim to do $2 million over time, okay?
Wow.
So I'm still being quite conservative, I think, but it's more for the discussion than for the accuracy of the exact number.
Yeah. Okay.
So, and the point I wanted to make then, once you've looked at all this, I'm done with this topic of the Starlink valuation and stuff. Now, just talking real quick about the IPO. Let's assume it's at the end of next year, and end of 2024, because by then, the recurrent revenues will start to be coming, okay? People will start to realize, okay, there's so many people that pay for the service, and this is the margin that Starlink can generate with the new satellites. Also, there's direct-to-mobile, which adds a little bit on top of it. So maybe it's a good time. I don't know, we'll see. But my point is the following. If you decide that the company is worth 1.6 trillion, because the FCC will approve the plan, for example, maybe your calculation gives you 3 trillion. I don't know, it's possible. I've seen it. I've seen 3 trillion playing with the numbers. And Tesla, according to you, is worth 5 trillion or maybe 10. You might have to say, well, I'm going to keep a lot of Tesla, but I'm going to put a little bit aside to buy some Starlink shares, I don't know. What I'm thinking is, if Tesla is worth 10 or let's say 9, and Starlink is worth 1, maybe I'm going to take 10% in Starlink. Of course, depending on the stock price at the time, but just to give you the idea. What do you think?
Uh, I am I am Tesla true and true. I think that robots and I can't imagine another company beating that. But are you suggesting that Starlink and SpaceX could actually be worth more than those two?
Yeah. No, I don't think more for sure. I just think
Yeah.
there's a nice growth, and also it's a great technology for the world as well. You know, not just renewables and labor, but you know, communication is also super important. So for me, it's part of it almost. You know, so I want to make sure
Yeah.
I have
I
a
think
little bit of it.
it's a big deal, of course. And what's surprising to me is that the communications alone for Starlink is such a massive business. I did not realize how big that is. But where my mind goes to is that when they go to Mars or when they go to asteroids and do minerals, that is now possibly even bigger than
Yeah.
robots. I don't know. We'll see. They're so both so big. Yeah.
Yeah, exactly. And you know what made me think of all that actually is there was this interview by I don't know if I will say his name correctly, but Ron Barron. Is that correct?
Hmm.
Yeah. Yeah. Okay.
Yes.
So you know, this guy is awesome. He really understands everything,
Yeah.
and he talked to Elon Musk and to people at
Yeah.
Tesla, and he has a good view on Tesla. I think better than me for sure, and most people I would imagine. Uh, but he also said in an interview that SpaceX, in his mind, will become the most valuable company.
Mm.
And I think that was 6 months ago, or maybe a year ago. And when I heard that, I was like, "It cannot be right. Like, how is that possible?
Mm.
How? Like Tesla will have bots, you know? Come on."
Yeah.
And then I started to think, okay, well, if you start to add the numbers, and if you have Star Shield,
Yeah. Okay.
and the launches,
Multiple trillions.
well,
Yeah.
maybe you go to the 10 trillion as well. I don't know.
Yeah.
I'm not saying this, but I think this is
Yeah.
what Ron Barron was alluding to.
Okay. Well, let's go back to Tesla, which is my darling. That's where all my money is invested in
Absolutely.
Tesla right now.
Well, same
And
here.
you're making me think about, if I can, and you'll talk about this hopefully, is Elon going to give Tesla shareholders the opportunity to invest in Starlink and SpaceX? But let me get excited about Tesla again. So tell me more about how is it that Starlink can actually help Tesla?
Absolutely. And let me preface this by saying that I also am fully invested in Tesla. You know, 100% of everything I
Yeah.
own is really Tesla. Well, it's not true. I also own 2 Teslas, so I guess not
Exactly.
100% stuck, you know.
Yeah.
But yeah. Anyways, so, and what I'm also super passionate about is how can your Tesla access the internet via Starlink? Essentially, that's what it boils down to. So here I've put two pictures just
That's a
showing
joke,
you
Rich.
what people are trying to do, okay? There's a guy, I mean, there's a lot of people. The one on the left side, I've seen at
Yeah.
least 3, 4 different people do it. I'm sure there must be like maybe hundreds by now.
Yeah.
Because they're like, okay, I have my Tesla, I want internet. Like, and I use the Tesla has wheels, so it has to move, you know. And sometimes I'm in the middle of nowhere, I want internet high speed. So what do I do? So they put this. The problem with this design though is they cannot drive like that. They have to like unscrew it and put it down, put it in the trunk when they drive, and then they have to set it up. So not like a great design operationally. You cannot use it while you're driving, but still at least you have a place to put the antenna. Okay. And on the right side, I think is incredible. Some people, sort of, I don't know, it's not reverse engineering, but they sort of opened the case of the antenna. So you have to really like, I don't know, like cut it. Like you have to cut it. You know, so you buy this thing, it costs $500, and then you cut it open and hope that it's still going to work. You know, so for me that's pretty mind-boggling. But then there's a company that sells you the stuff you see around it. Okay, so a company 3D prints this thing, and they will even open it for you if you don't want to do it yourself. And so then you can just stick it on top of your car or your RV or your whatever. And now it's really flat in the airflow, and you can use it while driving. So I think it's quite incredible. Of course, the antenna will not swivel anymore; it will not rotate. But that's okay because the antenna doesn't care. In the end, it can still reach those satellites. So yeah, I thought that was pretty cool to share.
Absolutely cool. I mean, we already know that Starlink can now function in mobile, right? They're selling it to cruise ships, airplanes. And so there's no reason why a car, while moving, could have full internet access. And if you have robotaxi,
True.
you're going to want to have, movies watching in as you go. So yeah, what is this? Tesla owner Silicon Valley,
exactly.
John?
And just before talking about this tweet, I just wanted to mention that there's different types of antennas. So the one sold for houses is a smaller version. The one sold for cruise ships or for airlines is a specific type designed for the use case. Okay, and so that's why, since they're different designs, you wouldn't expect to see the house antenna to be on the car, but and also they're not really approved for moving vehicles. But anyways, it still works. So yeah, let's go back to the tweet then.
Okay, go ahead.
Exactly. All right, so that's a tweet by Tesla owner Silicon Valley, asking if Tesla will be getting Starlink if you pay for premium connectivity, which is a $10 per month option that gives you 4 or 5G in Tesla. So the question is, if I continue to pay those $10 per month, once the service is available, the direct-to-mobile service, will I get access in my car? And Elon Musk says yes. And when I saw that, I was super excited because I had, of course, a hunch that yes, it's going to happen, but I'm not really sure. And now seeing this, it's like, okay, that's a certainty now, and it's pretty amazing. The reason it works is because all Teslas have a 4G modem, and that is sufficient. It's like a cell phone in the car. It's sufficient to connect to the 4G towers, so you get internet access on land. And the technology that Starlink offers with direct-to-mobile is to have those, those 4G towers, but in the sky. So they're further out, but the antennas are super efficient and they are able to communicate. So this is my vision of how things will unfold. There's 2 steps, according to me, to get internet in your Tesla. Step number 1, this is what we've been discussing, the direct-to-mobile. So T-Mobile for now has the exclusivity on this technology, on this service by Starlink. It uses their frequency spectrum allowance by the FCC of 2 gigahertz. Okay, and when is it going to start? I'm thinking end 2024. Maybe before that, I don't know, but sort of I guess end 2024 is a good date. And so any Tesla can access it, but you only get very basic online access. So you cannot do video streaming or anything. Why? Because it's very, very low speed. Why? Because as I said earlier, it's maximum 18 megabit per second, and that's shared by all users within a very large area. Okay, so it's really, I wouldn't say just for emergencies, but it's for like small things. Okay, we'll look into this in more detail, but let's look at step 2. So what is this? This is like the guy with the antenna that he put on the car. So it's putting the huge antenna, but on the car. And how to do that? Well, I am thinking, I don't know, maybe call me crazy, but I think the only shot that Tesla has is to integrate this in the glass roof. I don't really see another way, because you cannot stick this antenna inside the metal of the car. And you don't want to have something stuck on top of your car. You want to have something on top of the frunk. It would be ugly. It's not good for the airflow, for the aerodynamics. And so I think the glass roof is the only place that you could put this antenna. Okay. But what does this help you to do? It helps you do video streaming. You can have a Wi-Fi hotspot in your car in the middle of the desert. And I would think 50 megabit per second per car is probably plenty. And that helps reduce the size of the antenna. So that's my guess. My gut feeling is something around those lines. But do you want to sort of think a bit more about the different applications?
Okay, let's do that. Absolutely. I love the glass roof idea on glass antennas built in. I think that makes a lot of sense. I'm just trying to think of what happens when a Cybertruck. Do they have glass? I don't think so. And
yeah. There's definitely a glass. Yeah.
Okay. Because I can see that. I'm guessing that the Gen 3 platform is going to be based on a Cybertruck kind of platform.
Yeah.
That's a guess on my part.
On the Cybertruck, the whole windshield going all the way up to the top of the triangle, that's all glass, right?
That's right.
That should work out well. But yeah, so I put this image here just to show that there's already companies doing antennas embedded in glass. So that's a company called AGC. And what the words here mean, like 4 elements by 2 polarization, shows that this is an electronic antenna. So I think this is not enough element to be steerable, but essentially, if you duplicate this, if you have like, I don't know, 500 elements, then you can have an electronically steered antenna, which is the same technology as today's Starlink antennas, okay? Which is needed for connecting to Starlink. And so yes,
amazing.
Essentially what I'm saying is this would be compatible with Starlink, and this is why I think at some point in the future, maybe in 2030, you know, but Tesla will do this. I mean, if I was Tesla, I would do it. So that's why I think they should.
That's crazy. Anyways, you're saying that it can actually, before we jump there, it can actually follow the satellite as it's moving.
Yeah, but without moving, just because of how the antennas, like they're super well synchronized, and one will send a signal, and the next one will send it just after. And if you add all these signals together, those super small signals, it ends up being a big signal going in one direction. And if you change the synchronization, it will move to another direction. This is how the current Starlink antennas work.
Yeah. Okay. Interesting. So cool. Okay. What is this? This is what is this?
Yeah, this is just for the the techie maybe part of your audience. Maybe some people would like to see what polarization are possible and modulation and stuff. But the real reason I put this slide is just another example of a company doing antenna integrated in glass. So if you look at the second picture, which is B, glass integrated 5G antenna, you can see that it's a transparent glass antenna. And you can see, if you look closely, there's a little bit of a, I don't know, gray shape inside, and that's the antenna itself. And that's what maybe will be on those Tesla glass roofs.
Okay, so it is absolutely possible to do a glass roof antenna. Oh my God, this is so good. It's exciting. And, I mean, yeah.
Yeah, and what's good is that Tesla also makes their own glass roofs. They make their own glass. So
that's obvious like it is. I mean, when you think of a robotaxi, you're going to want to have entertainment. You're going to need to be able to watch something inside, but also you need internet access. So
exactly,
it has to happen. Exactly. All right, so this is Tesla glass. You were saying that they make their own glass.
Yeah. So
what's this?
Because I just wanted to mention they make their own glass. So they have this capability of doing like incredible work on the glass, making it strong. We always talk about how many elephants can be on top of Model 3. So Tesla has this capability, and then SpaceX has the capability of making the antennas. And so, yeah, exactly. So this screenshot here shows that very recently, the FCC granted an approval to SpaceX to test 200 new types of antennas. That's incredible. So it means that SpaceX has in mind a large number of antenna designs that they want to try and iterate on. And some of those antennas will be like larger antennas for ships. Some will be smaller for whatever, for the home. Some will be maybe smaller, and some may be the glass antennas. I'm just speculating. This needs to be clear. Nobody told me anything about this. My colleague, I have to be fair, that I asked my my startup partner, and I said, do you think, like, how can we put Starlink on a car? And he said, you have to look at glass, man. This is the only place, So I started to look into it, and this is why I came up with this stuff.
Okay, wonderful. That's so brilliant of you. I think this looks good. But here's my friend Ellie in space. She just moved from Seattle to Austin, and she has a YouTube channel called Ellie in Space. And so she's holding a Starlink. She's got a number of videos on this. But there is this comment here. Where did this come from? SpaceX is developing user antennas 50% smaller than this. So they're going to keep getting smaller and smaller, huh?
Yeah, so I took the liberty to take a screenshot of her video, which I thought was really awesome, and I think more people should watch it. I put the link here below, by the way. And so this is something that she says, and so if you watch her video, she will say, oh, this is the new SpaceX facility that they're building. Insane, out of nowhere. And what they will build inside of this building is Starlink user antennas like this one that you see. Well, this is the older version. So they will build a new version of Starlink antennas themselves. In the past, they used to outsource user antennas, but now they will do that internally. So that's one more thing that they insource. That's crazy. And so that's why they're going to be able to do different shapes or different sizes. And what she's saying is that someone that she knows at SpaceX confirmed that they're doing a smaller version that is potentially portable and battery powered. So now you go hiking and you have like high-speed internet. Insane. Like, I want this now,
So they make their own glass, they're making their own antennas, and people are saying that they're going to make different kinds of antennas, smaller versions. So it's all coming together very nicely. You're putting the dots together. Okay.
Yeah. Cool.
So let's see what else you have. Oh, okay. This is it. Applications time. Finally, we get to the application time. Let's explore and brainstorm.
You get excited.
Yes. Tell me what you thought of.
And me too, actually. So yeah, I was brainstorming a little bit. And I was saying, okay, what can you do with the step one, which again is the very low speed internet? So for the car owner, the typical stuff that is text-based, essentially anything that is text-based or eventually even voice-based is possible, but only in very sparse areas, like not in the cities. So search, for example, you search for a hotel or a campground or whatever, the search will be enabled. Traffic over navigation, they're probably not going to be a lot of traffic, but still it's going to be capable of doing that. Sharing your location with the family, if they have the Tesla app, they will be able to see where you are, although there's no network. So that's pretty important, even for safety, right? Profile sync, you move your seat. If you move your seat or the wheel, you press save, and then it's actually saved in the cloud rather than just locally for this time. Not super important, but hey. More important is remote control with the Tesla app. So anything you do normally once you have internet, well, you can't really do it now. Say you're on top of the mountain, you're going down to your Tesla and you want to preheat. Well, you can't really do it if you don't have signal on your phone and in the Tesla. So now with this, the Tesla will have internet access. And now your phone will also need to have internet access. And that's where you buy either the T-Mobile or the eSIM that Starlink is poised to offer at some point. At some point you will have another SIM in your phone that is Starlink, I think. And so this will be used only in those type of situations. SOS, super important. You're in the car in the middle of nowhere, you have a problem, an accident, you press the SOS button in the screen. It only works if you have 4G, but now it will work also if you don't have 4G. And I think that's maybe one of the most important ones. And then other things is phone call, messaging, maybe even get a low-res image from the cameras. Let's say you're on that mountain and you want to see what's the car doing. You will not have a video like you have now with the Sentry mode, like remotely, but maybe you can take pictures and get those pictures sent to your phone. It's better than nothing, right? It should be called better than nothing, which is also what Starlink was called before,
Was it?
Yeah, honestly, because that's what it is. It's better than nothing. It's not great, but come on. Yeah, and then if you move to fleets, do you have any comments on the for owner section or?
Yeah, well, the only one I really was wondering about was whether or not you think car-to-car communication is useful. Not at all. There's a debate whether or not that matters.
Yeah, I have something about this just later. If you want, we keep it for the next.
Let's do that.
The slide after the next. Yeah. Okay. So for fleets, just rental management. Basically, know where the car is, if it's going fast or whatever. Same with robotaxi management and semi management. That's all things that a fleet company will want to have access to the internet anywhere, so that you know where the car is and what it's doing, and even provide assistance if needed. All the services make sense, right? But the great thing is, what happens when you have high-speed internet in the car, right?
Yeah, this is all very, very good. This part I can see is going to be huge. Right. So as we get to fleet management, especially like I said, robotaxi management, I was talking to my friend, and he has a big two-row fleet, and the issue is that he needs to see where all of his cars are all at one time. He doesn't want to open up the app and find out where that one car is and that one car. He wants to be able to see it all in one place, and this could easily manage that. Nice.
Yeah, exactly. And again, that's going to be included in the premium connectivity, okay? So you don't pay extra to access all these services when you're in the middle of nowhere. I think
Nice.
it's awesome.
Okay.
I think it's
And
great.
this is what you were saying was equivalent to what Apple's offering, what we all heard Apple's emergency communication is?
Yeah, but I think the difference with Apple is that this year is much easier to use. The Apple, you have to take your phone and sort of orient it properly with the app they give you, and then it's going to work. And you can do an SOS and SMS, and essentially that's it. There's not so many services, but I think this will give you more services, and it's all going to be embedded in the Tesla, so you don't have to do anything special or different. The car will know, am I going to connect to 4G or to the satellites? And you don't have, it's transparent for the user. It's super user-friendly, like Tesla likes to do, right? So
I wonder if that's going to be used for the bots as well. So now you know where every bot is.
Well, if they're in the factory, it's not that useful, but if they operate outside, again, in the middle of nowhere, then it's going to be very useful, and sure, you can bet they will have it, of course.
Okay. Now let's get to
this will change the world. This will change the world, okay?
I love it. Absolutely agree with you. Okay, so high internet speed, which is even crazy that this is even possible. Go ahead,
man. Just thinking about it makes me just so happy, It just makes me so excited. It's crazy. So what I like to do, what I like to imagine, what I spend time doing when I'm on YouTube, when I don't watch your channel, because normally I watch your channel all the time, but sometimes, I watch already all your videos. So while I wait for the next one, I also watch other videos. And many of them is like camper vans and RVs. At some point, I think I will buy a camper van. And the reason I'm not doing it now is that there's not a good option that's electric. I think once there's a good electric camper van that I can convert, van that I can convert to a camper, then I think I might pull the trigger, and that's going to be a Tesla. Okay. So once Tesla has the van, then I will buy one and convert it into a camper, is what I'm trying to say. And what I want is to have internet access inside the thing. I don't want to fiddle with antennas and stuff. I just want to be there and it works. And then give me Wi-Fi, and I can, game if I want to, or I can do, watch YouTube or Netflix, or I can do video conferencing when I'm in the mountain, when I'm at the beach, when I'm, in a forest. It doesn't matter. Well, the forest, you have to be careful with the trees around you because that doesn't help with the signal, but you know what I mean. You can be anywhere and you can do all these things that you normally do at home easily. Like, it's transparent for you. Man, can you believe this?
That's gonna be good.
Anyways, that's for the owner. I don't know if you have more ideas that I didn't cover for the owner's part.
Yeah, I mean, I don't. Except for, like I said, vehicle to vehicle, and then the robotaxi, right? So when that happens, you've got there. You called it fleets, but it's when a person is using your car and you're doing robotaxi, and you're allowed to, you're going to want to have entertainment. And right now, you can't do that. You need to have Wi-Fi to be able to watch Netflix or to do the video conferencing. But this is a critical thing, right? You need to have high-speed internet wherever the car is driving to entertain you. So, it's just, and then imagine if you're on a what do you call those? The boring company, and if you're in a train, if you're in a plane, all of these things, right?
I agree. And I just call it fleet to differentiate from like owner, because the owner is not in the car, it's someone else in the car now. But yeah, robotaxi, semis, you need a lot of services. You need to provide those services to the person that's in the car, who is not necessarily the owner. So entertainment, as you said, it can be also video conferencing, anything that you need Wi-Fi for. You want to make a phone call, but the thing is, this works if you're going between cities. If you're inside a city and you have 4G, so that's not very useful. But if you are outside of 4G coverage, then it's extremely useful. And for semi, think of the time when semis don't have like full FSD where you don't need a driver. There's going to be a period of time, maybe it's going to be 5 years, where you have drivers, but they don't do much. They just watch the thing drive itself, right? But still need to be there. And so what do they want to do? They're in the middle of nowhere. They drive long distances between cities. So these guys, they want entertainment, as you said. They maybe want to call their families with video call, like FaceTime and whatnot. So now it's going to be possible, and it's going to be easy. I just love it, man. It's just
sense.
Crazy.
Yeah, because you need the antenna it can really only be applied to a Tesla car that has the antenna built in, or maybe they will be able to sell a separate Tesla antenna. But this could be a massive differentiator for Tesla cars. I'm just trying to think how big of a competitive advantage this might be. But would you buy a car if it didn't have high-speed internet as you go everywhere? I mean, that's assuming that other cars even able to capture, be able to do some version of robotaxi. Let's say that Cruise and Waymo, they're you have an option to take their robotaxi, but if you don't have access to internet access, you have no entertainment. How does that work, right? Maybe you can just say that you're going to use your cellular, and that should be fine. But this could be a game changer. We'll have to wait and see. Yeah.
Yeah, and the way that I envision this is obviously this will cost more. It's not going to be the premium connectivity. It's going to be more expensive on a monthly basis. But the way I think it's going to work is maybe if you have Starlink at home, maybe it's going to be included in that subscription. So maybe they will say, you have a Tesla and you have a Starlink at home, so you pay just one time $100 per month, and you can use both. Could be. So I think that's a nice way. So you think
that they're going to get into that too, which is Starlink at home. So they're going to basically take over Comcast and AT&T.
Yeah, but again, maybe not initially in the dense areas, but over time, and there's so much capacity that they can serve a percentage of the cities, I think. But potentially, like a small percentage of cities, a small percentage.
Okay. I do want to get back into this, which is car to car via Starlink or locally. So a lot of people were debating whether or not you even need the car to car communication. So especially if it's robotaxi, one car knows where the other cars are. And if every car had some sort of knowledge of where the other cars are, and maybe even in communicating with the stoplights or some sort of government city regulations and so forth, it can communicate. So basically the cars are communicating to each other. Some people say that that's important. Like, you need 5G and it needs to be able to have that immediate, microsecond reaction to that. Others are going, nope, you don't need that. Humans don't have that. Humans can drive normally. What's your take on all this?
Yeah, so I think that's a very interesting question. One thing I want to point out first is Waze. You can use Waze to signal to other users on the road, oh, there's an accident there, so slow down and stuff like that, okay? Like the road conditions. So you generate information and data by pressing a button physically as a user to inform other drivers. And this is great because you also receive that same information from drivers in front of you. Now, the cars with the cameras and the FSD software, they can recognize a car stopped on the side, or there's a hole here, or whatever. There's an emergency car, so be careful. So all this information can be detected by the car itself now. You don't need to press buttons. So I suspect at some point this will be included and shared with the cars of your brand, or maybe multi-brand at some point. But let's say it's a Tesla. Any Tesla will then be able to share this type of information. And the question is now, that being one of the use cases, how do you share this type of information? And having an engineering background, I'm thinking to myself, well, you can share everything to the cloud and then send it back to all the cars. And I think, this is what Waze is doing. So obviously it's possible. And I think that's a very good way to implement the system, because also then Tesla could use the data and do something with it. So that's an advantage for the cloud base, so via Starlink. The advantage for local is that it doesn't require that infrastructure, that satellite communication hardware in the car. Like a lot of cars can just be equipped with a normal radio and communicate with each other quite easily and for cheap. So that's an advantage for local. And as Amy was mentioning the other day, aircraft do that for collision avoidance. It's called the TCAS system. And they just chat sort of locally using radio, and it doesn't go through satellites or anything. So that's also possible. And I'm not set on one idea or the other. I just think at some point this will probably happen. And it will make sense, to increase safety on the roads.
I did come up with another idea of, imagine if every single, car has 8 to 12 cameras around it, and it can now, whether it's low latency or high bandwidth, send that back up to Dojo, which is Tesla's supercomputer in the cloud. And eventually Dojo is going to be as big as Amazon's AWS, right? It's Dojo as a service. They'll be able to sell the supercomputers, but they will have AI, right? So all the extra data that they can capture, and like you said, almost like a Waze, but automated Waze, as it drives around, it captures road conditions, so forth. It sends it up to the cloud, and then the AI can eventually kind of have a sense. It might even know what the weather is, what the future weather is going to become. It can do all sorts of calculations we can't even imagine, machine learning and AI applied to it, right? So that's like, if you apply the ability for a lot of things, whether it's a camera, to communicate back up to the cloud as fast as possible, wherever it is, it just builds on Tesla's ability to do machine learning and AI on it. So it's going to be massive, massive, massive potentials.
I agree. The possibilities are endless.
Yeah.
Yeah, absolutely.
And then, so that was one. And then there was another one that I thought of, which is, can't remember right now, but yeah, just, I think Dojo as a service, this could be something that even just applies to that, right? What supercomputers can do with all this data that can now be sent to the cloud in real time, or close to real time, is amazing.
Absolutely.
Even like virtual reality or augmented reality and those kind of things. Do you think that Tesla is going to get into a mobile phone? I mean, people have been, that's like a silly kind of, but I just, what's your thinking?
I'm not, let's say as a Tesla investor, I don't think I'm so into this idea. I mean, I'd rather Tesla focus on technologies that can really make a difference in the world, Maybe I lack vision on this part. Maybe I don't understand some things that could be a lot better. But honestly, I'm pretty happy with the phones we have right now. And I'm pretty happy with Tesla doing energy, doing EVs, doing doing AI. All these are fields that are very complicated, and they get really great engineers to work on these difficult things. I don't want to waste the talent.
Yeah, I don't think they'll ever get into the mobile phone. We've already heard him say that the mobile phone is actually very slow in communication between your brain and the actual, finger input. And so if anything, it's going to be AR glasses. I can see them possibly doing that because they need the vision to teach their bots. And so once the bots can see what you're seeing, then you're teaching the bot everything and anything, how to knit. Once it sees how I'm knitting, all of a sudden it picks it up and knows how to do it, right? I can see them doing that, but you've already heard Elon talking about Neuralink being the fastest, most logical first principle approach to, speeding up the ability for humans to communicate and to interact with computers. So I don't think they're going to do that. Like you said, there's so much other opportunities. Yeah, I agree with you there.
Yeah.
Oh my gosh.
I don't know. We'll see, I guess, but I don't think it's very likely on my part, anyways.
Okay, so this is very, very exciting. I appreciate this, Julien. You have basically gotten me so excited about Starlink and SpaceX. You've given us a kind of an overview of where they stand today and how much of a competitive advantage they have, and the ability for them to, it's like just literally a few years ago, feels like they were talking about this impossibility of being able to use satellites to blanket the low orbit and then be able to provide internet access to everybody. Now they're doing it. They're doing regular rocket launches. Soon we're going to see Starship level, large, massive rockets going up. And you showed us why that matters. And then the benefits of the internet access to Tesla and to the world and the population, of course, but immediately to our investment in Tesla, it's going to be pretty big. And you showed that, oh my God, I'm just doing an agenda item, go back. But I love the idea that you showed that the potential for glass is where they're going to embed the antenna, because I was wondering about that. I didn't know if it's going to be just an add-on to somewhere, but if they can use glass, it's seamless. And then this is a requirement for robotaxi. Yeah, very, very cool, Julien. Appreciate this. You're the best, man. You're so smart. You're an airline pilot yourself. You're a developer. You've got this incredible interest in Starlink. I'm so glad you did. And I don't know anyone else who could have gone through the detail like you did, compared everything. So everybody should check out your startup. What's your startup's name? Is it?
So we just changed it. It was called Future Labs, but now it's going to be called Dynamic, like dynamic orbit.
I saw that earlier.
We're in process of doing that. Yeah.
Okay, love that
But
name.
yeah, you
Yeah.
check my Twitter, and I think at some point we'll announce it, and we'll have a website and stuff.
Okay, thanks, Julien. Yeah, so please follow Julien on Twitter. He's a handle at Julien VM. That's Julien VM, and we'll put a link there. And this was great. Okay, hopefully everybody learned something today. I'm sure I got brighter. I hope you did as well. Please leave a comment and let me know what you think about everything. And I think there's a lot of use cases we haven't talked about. I'm sure there's so much you guys can think of. Share that in the comments. Appreciate your time, Julien. This is fantastic. Thanks
a lot, Herbert.